Good morning, everyone, and welcome to week 3 of Foundations of Computing. I'm glad to see that many of you are still here in the room, and to all of you who are still out there, don't worry, we have got you covered. So who remembers what this is? At this point, this should be pretty familiar to you. Yeah, that's our computer over there. And it's also going to represent the container for all our different storage, all our different memory, all our different variables that we are going to use to execute our program. Now, it wouldn't be particularly useful for us if every variable in the computer's memory was available to every program. And maybe we can hear a little bit about why that is from, it was Peter. Peter, why is it a bad idea if every program in the computer's memory has access to the same variables?
That the computer cannot recognize what.
Okay, that one doesn't seem to be switched on. Is it got a green light on it for you?
Yeah, it does.
Does? Okay, you're just not speaking loud enough.
Okay, maybe that the computer cannot recognize what exactly is the number or the value of the variable is.
So the computer could still recognize what the number of variables is and what they are, even if we gave access to every program, every variable. But there's something else that might be worrying us a bit. Driti, because you helped out this morning, maybe you can give us a little feedback on this particular problem.
What?
So why might it be a bad idea if every program in the computer has access to all of the same variables?
It's gonna get confused.
Get confused? And what's dangerous about it? Like if my program running under my user has access to the variables for your program running under your user, what could happen?
Then it's going to not run the way you want it to run.
Well, not only might it not run the way you want it to,
My stuff.
yeah, say it again.
That's my stuff.
That's my stuff, that's my variables. And she doesn't want me interfering with her variables and messing up the things that she's doing. Not only because it might interfere with the way her program's running, but it would allow me to actually read things that should have been private to her. And what our operating system does, one of the key things that we have an operating system for, is to separate out permissions and privileges. So who gets to read what part of a computer's memory? So just because I have a function in one part of my program doesn't mean that function should be able to read the variables of a function somewhere else in my program. Or one program that I have running on my computer, my web browser, shouldn't be able to read my email passwords. And so this introduces for us in the scope of a programming language the idea of scope. Now, scope is this same kind of idea of separating different privileges and different viewpoints to different parts of the same program. So this is a little bit of a security function, but even more so, it's a bit about what both of our volunteers were saying before. This is so that different parts of the program can't interfere with the other variables and make changes that those other parts of the program weren't anticipating. So if we can imagine inside our larger program, we have a whole bunch of sub-programs. And what do we typically call these? This different subunits of an individual program? Functions, yes. And so one way that we might conceptualize of this is, well, there should be a strict relationship between the different functions such that the only way the functions communicate is through their return values and through their input arguments. So if we want to compute f of g of x, the only way that f knows what's happened inside g is by passing something through the return value. Now, we want, as programmers, to perhaps have a little more flexibility within our own programs. And so Python and other programming languages give us powerful tools to define the scope of our variables, to say which parts of our program should have access to which of the variables. So let's start off with the simplest of scopes. And this is a scope where all the variables are just restricted to the individual function in which you are writing it. So here I have my individual function within my program, and it's going to compute some data about me. It doesn't really matter what. But if you're outside this little box in another part of the program, that part of the program is not going to be able to see the two variables x and name. So let's give this a try with some code. So here we have Visual Studio Code. This is just like the website I showed you, vscode.dev or cs50.dev, except this time I'm actually running it on my own local computer, so I don't have to rely on the internet. So let's create a function here, def foo, and that'll take in an input x. X equals x plus 1, print x, and then I'll do def bar print x. Okay, now I'm just going to get my terminal ready. So all my files are in this week, week 3a. Okay, so I have my terminal, and now I'm ready to run the file called code.py. Only, that's got a filled-in white circle there. In the case of Visual Studio Code, that means that I have forgotten to save my file. So I'm going to go ahead and save it with Command S. Now I'm ready to run code.py. What's going to happen? Any guesses? Guesses from the audience? What's going to happen when I run code.py? It was Isabel.
There's no return, so it's not like
There's no return, so it's not going to like it. That's one possible answer. Another possible answer? I haven't called either of the functions, so what was your name? Aaron. So we're going to go with you for a minute, and we're going to fix this code up bit by bit. Okay, that's on. So Aaron, tell us about what's going to happen.
Well, when you run the code, nothing's going to happen because you haven't called either of the functions, so it's just going to return nothing, really.
Okay, let's see if that's indeed what happens. It's going to run, but it will return nothing. So Python code.py, it indeed does nothing. Okay, so how could I fix this?
Well, you could print the function.
So I could run the function and just do something like this. So I could nest
Basically.
the foo function inside the print function. And should I just try it with some value?
Sure. Use
Okay.
any variable.
So let's try print foo of 1. And will this work? What will it do?
It should print x equals 2. Well, it should print 2, basically.
Okay, print 2 and then none. Why is it doing that? Okay, maybe we'll run through the instructions one by one. Okay, the first thing that happens is I've told my computer I want to print something. What do I want to print? I want it to print the result of foo, whatever foo returns. So now I go into foo. Foo has added 1 to 1, and so x is now 1. So let's add a comment, just for the time being, to keep track while we're debugging. And then we print, sorry, x is now 2. My mistake. And then what are we doing here? What are we printing?
We're printing the new x value.
So print 2, and then what happens?
And it prints 2, as seen in the terminal.
Well, it's already printed 2. Now what happens when the function ends?
The function terminates, so
Function terminates.
does it not terminate because there's no return?
No, it does terminate. It just doesn't give anything. You've kind of hit the nail on the head there. It terminates, but it hasn't actually given anything back to the function that called it. So if we were to write something like this, result equals foo of 1, and then print result, we haven't actually given result anything. We haven't returned anything from our foo function, and so result is going to be none. This is the default type that Python functions are going to return when you don't add in a return statement. So that explains why when we run it, we get 2 from this print, but this print is actually going to return none. So how could I fix this up, Aaron?
Could you just return print? Would that fix it?
So return print, like that?
Yeah, I think so.
Okay, let's give that a try and see what happens. Still not working. Does anyone have an idea what the fix should be? Alishka?
get print x within the function. Just
So
return x.
if that's totally right. If I get rid of the print, now this should work. The reason it didn't work when I was doing it the way you suggested before with return print is because print itself is a function. And so what does print return? Print in Python doesn't actually return anything. So it wasn't giving me a result to return back. So if I wanted to do what you were suggesting before, I really should have had it on 2 separate lines. So now I'm printing twice, it's going to work. And then I'm also going to print it a second time when I come out of the function. Okay, so that gets us a little further. So now foo is returning something. And now let's say I'm going to print foo of 1. And now I'm going to print bar. And I'm going to get bar to return x as well. So we've fixed up this challenge. And Aaron, do you want to pass it back to Charlie behind you? Yeah, or either way. Charlie, do you want to? No? What was your name?
Jordan. Jordan?
Jordan? Awesome. So Jordan, what's this code going to do? Oh, I've just spotted a mistake that I didn't intend to make here. So Jordan, what is this code going to do now when I try and run it?
It's going to print 2 and then 1 because x is not assigned in bar.
Okay, let's give that a try. It should print. Jordan says it's going to print 2 and then 1. And I'm going to make this a little larger for all of you to see. Maybe one size bigger is good enough. There we go. Whoa, local variable x referenced before assignment. So this is going to take us back to our picture over here. We have 2 different functions, only in this case, the functions are in different places within our program, and so they don't have access to the variables that were created inside the other function. So if we look at our code, we can see that x was created inside function foo, but inside function bar, x has never existed. X was never created. And so when I try to use x, I get this kind of cryptic error message, local variable x referenced before assignment. So this means we are talking about a variable x before we have actually created it. Now, if we were to do something like that, all of a sudden, our problem would be solved in one sense. But now we have an issue. 2 different parts of our program are now using the same variable name. So Jordan, what do you think will happen?
I think now it will do what I said before. It should print 2 and 1.
Okay, so let's try it. I can see that white circle, so that means I still haven't saved. I'm going to try it again. Now it does work as expected. What happens if I were to do foo of 2 now? What would happen?
We'll replace the 2 in the foo, so it will come out as 3 afterwards.
So let's give that a run and see what happens. So now I get 2, 1, and 3. And this behavior might appear a little mysterious because didn't we already set what x was before? Well, as Jordan was, I think it was Jordan or maybe Aaron was telling us before, when a function gets to the bottom, it actually destroys itself. Everything inside its box is destroyed. So whatever variables it had no longer exist. And now when you run the function again, it has to recreate all the variables from scratch. And so in this case, in our code, we're telling it that the variable x is a variable that it should source from whatever its input is, and that line is going to rerun every single time that you actually call foo. And this x is in fact totally separate from the x that's inside bar. These are what are called local variables. That means the local neighborhood that they live in is just the function in which they were defined. And you can actually reuse the same name in different neighborhoods. It's just like on 2 different streets, you can have the same house number. It doesn't mean that someone won't be able to figure out where to go. It just means that you have to determine first which neighborhood you're in, which street you're in, or in our case, which function you are in. But unfortunately, for programmers, we do have a notion of side effects. And these are functions, or these are, let me say that again, these are effects that a function can cause that impact something outside of its local scope. So when it can actually impact bits of the program that are beyond its own scope. And this can be valuable because it allows us another mechanism to pass information between different parts of the program, but also dangerous because it makes it harder for us to reason about our program. So let's consider the following case. I now have inside the main scope of my program, in the global scope as we're going to call it, a variable called x. And now inside my foo function, I'm going to have another value x. And let's actually write this up in code. So I'm going to create what we'll call a global variable because it is not inside any function, and x will be equal to 4. And I'm going to delete my bar function for the time being. And leave it at that. And we are going to run foo of 1 and then print x. So who's got the microphone? It was Jordan. So Jordan, let me grab that and we'll give it to someone new. And I know you. What are you doing here? Okay, let's see. Do you want to speak? What was your name?
Calvin.
Calvin, awesome. So Calvin, let me scroll up to the top again so you can see all the code. What is this code going to do? And I've lost sight of you. Put up your hand so I can see. There you are. Okay, Calvin, what's going to happen when I run the code this time?
X is 1, is 2, 1 plus 1.
Okay, let's see. So we're expecting that we're going to run this foo command, and then what are we going to print once more, Kelvin?
2.
2. Okay, let's see. Python code.py. Ah, it's printing 4. Okay, maybe we should try follow the logic of the code a little more closely. So we run foo of 1, and Kelvin, what happens? Where do we go in our program now?
X is equal to 1.
So we jump over to line 4 over here. So we've copied that number 1 into the function, and now our variable x inside this function is equal to 1. So now we do x equals x plus 1, so that is 2, and we return 2. Have we saved that value 2 anywhere?
Of 1.
So we haven't actually saved it anywhere, it's just a return value. So if we did y equals foo of 1, then we would be saving it in y, but we haven't done that. And now we print x. But let's go back to our picture over here. Are we printing the inner x or the outer x on that line?
Outer x.
We're printing the outer x. So if I look at my code and I see over here, well, that's why I'm getting 4, is because I'm not printing this x that's inside that foo neighborhood, inside that foo function. Instead, I'm printing the x that's available globally. But you might ask, well, what if I want to access that x? That x is a useful x. Well, in that case, I can do something like this. We'll see if it works. Oh, foo takes, that was an error on my part that I didn't mean to do. Let's do that again. Local variable x reference before assignment. So again, this is telling us about something the way Python works. So in Python in particular, even if the inside doesn't have the, where is that? Even if the inside doesn't have that variable declared, it's still not going to be able to access the outer one. So this is where we introduce a new keyword in Python. And this is the global keyword, G-L-O-A-B-L. And so now in my code, I can write global x, and suddenly what this does is it creates a link between the x that's inside and the x that's outside. So now my function foo has access to this global x that was declared outside of the scope of the foo function. So now if I run it, Calvin, what should we see?
2.
2, okay. Not quite. So let's follow the logic again. X equals 4. Now we run foo. So foo takes us to line 4, global x. So this now creates a link between foo and that global variable x that's declared outside its own scope. So x is now this x over here, even though we're inside the foo function. So x equals 4 plus 1, return that. So 4 plus 1 is?
5.
5. Great. I'm really getting you guys to do the grade school arithmetic here, and I'm glad we're making some progress. So, and then we can print that same global x because now we are back in the global scope, and so we are able to print that variable that was modified by a function, and that function is modifying something outside its own scope because we have used the global keyword. And so now our function has a side effect. The impact of our function is not just restricted to the variables inside of it, it is directly impacting the variables outside of it. Now this is, when we return something, we do not call that a side effect because that's just like the result of the function. That's not modifying something outside the function. In order for a return value to modify something outside the function, you have to have used that return value to intentionally change something. And the other thing to note is if we created other functions, they would not be part of this interaction between the internal x to foo and the global x whatsoever. They also each have their own scope. So what global has done, one more time, is it's created a link inside the neighborhood of this function, inside the scope of that function, to the scope of the larger program, of the larger file there. So, functions can also have scope. So if we look at the way my program is written, you can see that I have this function foo, and I've declared it. Where am I declaring it? I'm declaring it just inside the file, in a general space. And just like I have the variable x is not indented, is inside the global scope, this function foo is also inside the global scope. Now, if I want to be really tricky, and I don't suggest doing this because it will get confusing fast, but I could do something like this. And now I've created another function bar, but this function is inside the foo function, so it's inside the scope of the foo function, which means if I were to run bar over here, you can see it's already unhappy with me. Name bar is not defined, but if I'm inside the foo function and I try and run bar, this will work because the function bar is not inside the global scope. The function bar is just like a variable and it's inside the scope of that other function. Now, this might seem a little annoying, but it also allows us to hide different parts of the program for each other, just like we hide different pieces of information from different parts of the program to stop them interfering with each other. And one place where this is particularly useful is where we attach functions to objects. And we've already seen some examples of this. Where have we seen a function that is attached to a specific variable or a specific object in Python? Does anyone remember one? From, I think, the very first week. Okay, let's... Remind me your name again?
Tim.
Tim, that's right. And where's Tom? Is Tom here? No, only attended the first lecture. Okay, Tim, explain a little more what you were saying.
I think we had one which we used on lists, append, or maybe that was only in tutorial, but
Probably in tutorial. That sounds like an advanced tutorial thing.
like to uppercase or anything like that.
We did one of those.
Yeah.
We used string functions. So we used string.strip, if you remember. So if we had a string, we could use strip to get rid of all the extra spaces on the end. And we also used title, I think was the other one. So let's try one of those back in our code just to refresh our memory. I'm going to delete all my code so far and create a new string. And we will do this again. So my string, and then print my string. Okay, so this works as, oh, what have I forgotten? I can't see it. There we go. There we go. Okay, what have I probably forgotten? Just very quickly, Tim, sorry.
I don't know, to be honest. I'm just looking.
Probably just a space there.
Oh, yeah. Yes.
Something very simple. So we also want to keep our code formatted nicely. So I'm going to start that again. What is your string? Okay, but it's a sentence and it's not capitalized. Or maybe it's the title of a movie, so let's try not capitalized, but what we can do is we can run a function that's actually inside the scope of that particular object, of the string. So now what I can do is I can do .title. Now what is your string? Harry Potter. And it makes it into a title. It uses title case where the first letter of each word is capitalized. And the reason I'm showing you that is not because I care about the particular function .title. Of course, it's good to know. But this illustrates an important concept in Python, and that is of methods. A method is a function that is inside the scope of a particular object. And the way we run it is by using this dot syntax. So certain types of objects in Python, certain types of variables like strings, have access to a whole bunch of functions which, instead of having to pass the input to the function, because the function is already attached to the object in some way, that it makes more sense for the information about which object it's related to be contained inside the object itself. So I'll say that one more time a little more simply. So let's say we have a string, and we want to run some function on the string. Well, I could write a function called title. And then that function, I could tell it every time what string I wanted it to make into title case. But instead, for convenience, we could build a system where every string in our entire program has a function built into it that you can run, a method built into it, and by using the dot notation, you can access it and then run a number of different functions that are related to that particular object, that particular type. So you can also run the capitalize, and that'll do as you expect. So let's try. And now I have it in caps. Now, one other thing that I just want to show you while I'm here in this window is something called interactive mode. Now, interactive mode is probably what you're going to be familiar with in some parts of Grok. So this is where you can enter commands directly into the Python interpreter instead of actually having to write a whole program. And this enables you to play around with Python and see what the result would be without actually having to go and write a whole program and save it. And this can be useful in some instances where you just want to play around. So let me make my terminal much bigger for a minute, and I'm going to simply enter the Python command with no file name, no nothing. And this will take me to a screen that looks kind of like this. It's asking for some input, and then I can enter Python commands. So I will do x equals 5, and then press enter. And that has just run that single command. And now I could do x plus 3, and it'll show me what the result is, or I could print x divided by 2. And this just enables you to play around with different parts of Python quite easily. So let's try this one more time. And I'm going to call this my string. And now I'll show you one other feature, and this is going to carry over not just to Python, but to many different instances and settings inside the computer you might use, and this is called tab completion. So it's not going to work in every program, certainly not going to work in Microsoft Word, but if I start typing something, particularly on the command line or in this Python interactive window, and then I press the tab key, very frequently the computer is going to try and automatically complete for me what the command was. So in this case, I haven't told it anything other than the fact that I'm trying to use one of the methods attached to my string. And so when I press tab, the computer is helpfully offering me a list of all the different things that I might possibly want. So now I know my method is going to be one with a C. I don't know which one with a C. I press tab again. Now it tells me there's capitalize, center, casefold, and count. And so I'm going to run one of these. Count takes at least one argument. I actually don't know what that function does. So that's a bit of homework for all of you, is to go back and come to me when I'm back in 2 weeks' time and tell me what the count function does. Elizabeth, you know?
I think it's like you put in like character and it would tell you how many.
Okay, let's try that. Elizabeth says that it's going to count how many times a given character appears in a string. So let's try this with the letter H. It should give us 3. Elizabeth was in fact correct. Can we have a round of applause for that? Thank you very much. So this takes us to a new topic in Python. We've now learned about scope and about functions, but a lot of the processing that we're going to want to do with computers does not just refer to single objects. Who can give me an example of something in the real world that we're going to need a collection for, that we might process using a computer? And Tim, take the microphone back. Alishka, have you already spoken today? You have? Okay, sorry. Someone new. There we go. So where are we going to need to process a collection of things? In the real world, what's an example?
For example, if you're sorting a lot of things and...
Something more concrete, something real that you'd actually do. So don't think computer programming, think general real life stuff.
For example, if I have a collection of, say, figures and I want to sort them out, so does that count? Or...
So here's a really obvious example to all of you. Let's say you have lots of subjects that you've taken in your uni degree, and you want to collect all the subjects that you've done and figure out which ones you've done the best in and which ones you've done the worst in. So that is an example of sorting, because we want to know from best to worst, what are my best subjects at uni, but it's a little more concrete because it's something that you might actually do in the real world. But in Python, unfortunately, the methods that we've got so far, the tools that we've got so far, are going to make life difficult if we actually try and deal with this. So, what was your name, sorry?
Sorry, Angbo.
Angbo. Oh, that's right. We had you down at the front before. You were hidden in the background. Okay, so Angbo is going to help us code out variables for each of his subjects. And is this your first semester?
Yes, it is.
So we're going to make up a whole bunch of grades for every subject. Okay, so let's create a variable subject1. What's subject1 for you?
I take user interaction design.
Just give me a code.
UX, yeah.
UX, okay. Grade 1?
Like
You get to choose.
90, I guess.
90, okay. Subject 2?
Marketing.
And we'll just call that MTG.
80, I guess.
Okay, 80.
History.
Come on, you get to make up your own grades. Why aren't these all 100?
I guess 100 then.
Okay, 100 in history. That'd be a tough one to get.
Yeah, it is.
Okay, I'm going to stop you there. This is getting tedious pretty quickly because we're having to manually create a new variable for every single grade. And now if we want to process them, I'm going to have to write out something like this. If I want to calculate, let's say the average grade, I'm going to have to do grade sum equals grade 1. And what do I do next?
Plus grade 2 plus grade 3 and then divide by...
And then close that. What do I do now?
Divide by 3.
Divide by 3, and now I can print grade average. That's a pretty good WAM, particularly within 100 in history. But as you go on through your second semester, what are we going to have to do to our program? What's the frustration here as a programmer?
You're going to have to put more subjects in?
I'm going to have to put more subjects in, and then every semester that you go, this line is going to get longer and longer. I didn't even finish the first semester, and I've already had to type out each grade individually and add them together, and then manually figure out how many subjects there were. And if I'm continually doing this, let's say you're now at the end of your third year, and you've taken 300 points worth of subjects, this line in Python is going to get really long, and I'm going to have done a whole lot of manual work. And after all, the point of programming is for us to avoid doing this manual work, so I must be doing something wrong. And this is why in programming languages, we have a number of different ways to represent collections of items. Now, in Python, there are a whole number of built-in ways that we're going to explore during the semester to try different collections. We have sets, lists, tuples, dictionaries. Don't worry about all of these. We're going to introduce them as we go along. And for today, we're mostly going to focus on tuples and maybe a mention of lists if we get time. So let's go back to an example of a person instead of a student. And these might be some of my details. So my last name, my first name, the year I was born, and then the number of siblings I have. And we could just write that directly in Python as is in this comma-separated fashion with 2 round parentheses on the end. So let's take that and apply the same kind of syntax just to our subjects and our grades. And let's go back to our code here. So having seen that one example, how could I potentially represent each of these subjects? This is our first step. So I'll put it back up there for a second. And Angbo, do you maybe want to pass the microphone over one? We'll give someone else a chance. Oh, what was your name?
James.
James. It's on. You just have to hold it really close. OK, so if I want to use this syntax for a collection of items to represent my subjects, what would I have to do? So what was the first symbol in this syntax?
It's
The very first character?
open bracket
OK, open bracket. So we can start with that.
and
So we probably want the first thing in our collection. So what's the first thing in our collection here?
it's the UX.
So it is the UX, it's UX. And then for the next thing in our collection, we use a comma to represent the fact that we're up to the next item. So what's the next one?
MTG
MTG. And then
and history.
history. OK. So subjects equals this. And now I can print subjects. And I've created what we call in Python a tuple. So let me run that. And you can see that now I've created some object that contains all 3 of these things. And I can start to access it using the same index notation that we have already been using for strings. So if I do subjects 0, that should give me UX. Now if I do subjects 2, will that work? What do we think? Will that work? History. And then subjects 3, because I have 3 subjects.
Oh.
Okay. Indeed, remember in computer science, we typically start counting from 0. So even though there are 3 items, we can only get up to number 2 as an index. But we're still kind of missing something here because we don't have any of the grades. So what might we do to represent the grades?
You you add using.
Have to speak a bit louder.
Oh, I think like you add, I guess. Add on those subjects. Subject equals, for example, like
You have to tell me what to type.
like grade.
Okay, grades.
It equals to open bracket 90 comma t comma 100.
So now we've got this nice thing, which if I were to print grades, subjects, and print grades, grades, I'll have both the subjects and the grades there as collections. And so if I want to know what the grade was for subject 1, I could print grade 1, or grades 1, and print subjects 1. So that works, but there's something that doesn't feel quite satisfying about this. Is there something that feels not 100% satisfying to you as well? What is it?
It's like not in the same line, I guess.
Well, it's not on the same line as one thing. Maybe that's a formatting issue. But there's something deeper about our program. Does anyone have like a deep feeling of something's wrong with the world? There's more typing. Anyone else? And someone have an idea? Okay, let's. What was your name again? James, you want to get the microphone over there? Put up your hand. It's over this guy in the. What was your name?
Aryan.
Aryan. Aryan, what is wrong with the world?
Is it because like you can't, because the values are associated together. Now, since they're in different lists, you have to access them differently, even though they're like related to each other.
So it feels like the grade should be with the subject, but right now we're storing them in two different things, and the only way they're connected is because we're remembering that, like, okay, number 5 in that one matches number 5 in that one. So this is where we start to think about collections of collections. So do you have an idea, if I tell you collections of collections, that give you an idea of something I might be able to type to solve this problem? Yeah, go for it.
Is it where you would split up, so you would put the subjects and grades in the same bracket? You would, for like a certain subject like UX, you would then do comma 90, like the grade associated.
That sounds pretty good. Okay, let's try that just with one. I'm going to cut you off there for a second just to make it easier. And so what we're going to do is let's just do an individual subject for the minute, right? And so a collection for an individual subject will look like the combination of, it's a question, the combination of
the subject name and the grade.
Okay, so how do I do a combination of things?
So you would do bracket, and then the code.
Oop. And
then comma, the grade associated with the, so 90.
Okay, so now I have one subject.
Yes.
And I could do this for my other subjects as well. But let's say I just want to create the big subjects collection. So I want to make a collection of collections. So to make a collection, I'm going to put a bracket. And now the first item in my collection, in this tuple, is going to be this thing which is itself a collection. And then after that, I'm going to put a comma, and I'm ready for the second item in my subjects collection. And the second item in my subjects tuple should also be a tuple. So what am I going to type now?
Bracket again. The code of subject 2, then comma, the grade.
So that was marketing and 80, and then we'll do that one more time. Okay, so now I have a new subjects tuple, because tuple is what we get when I put the circular brackets on. And let's print out our subjects tuple. Okay, that seems pretty good. And now I'm going to print the 0th element in the subjects tuple and see what we get. And now I have both the subject code and the grade associated with the same index in this single object, in this single tuple. But now let's say I just want to get the grade of the 0th item. What would I type there? Arian, do you have an idea? How could I modify line 11? So I've already shown you how to access this tuple, the 0th tuple in the subject's tuple. So how would I now access the grade?
Since now technically you have to index like 2 times, so you would do another like square bracket and the index of whatever the grade is in that collection, so 1.
So I can, ooh, Elizabeth is shaking her head because I missed I saw that. Okay, oh, now I've got an extra one. You're getting very angry at me. Okay, so now I run it, and now I just get the 90. So let's break this down a little bit more just to make it slightly clearer. So what I'm essentially doing with this first index operation is I'm getting that tuple right there. And now once I've gotten that tuple, I can then print its first element. So let's just add another print so it becomes really clear. So that line 10 over here is accessing ux, 90, that tuple. And then on line 12, I'm accessing the first element of that tuple, which is now our grade. So we've got a few more minutes before Kat takes over, I think, right? Okay. So there are a few things that we might actually use tuples for already, and you can start to be creative with them in your programming. So one thing we might want to do is to return multiple values from a function. Now, knowing that a lot of you are very clever in this class, I want to see if any of you have an idea of how we could use a tuple to return multiple values from a function. Anyone got an idea how we might do it? Sorry, Alishka. I'm trying keeping a one time per person per class. Okay, Ariane, I'll take the microphone. Remind me your name?
Gabriel.
Gabriel, that's right. Gabriel, so how might we return multiple values from a function?
You can return a tuple.
Is that on? Check your microphone's on. Is it green?
Oh.
There we go, yes, so just speak into it.
We can return a tuple from a function.
We can return a tuple from a function, and thereby, even though the function is only returning one thing in a way, that one thing is itself a collection of other things. So let's try this out with our code that we prepared right before. So I am going to have a function, and I'm going to call this def get subjects. And this one isn't going to take any arguments, it's just a demonstration of how we might return multiple things from the function. And so now I can return subjects from this function, and even though it's only returning one thing, it's returning subjects, that one thing is a tuple, it's a collection of things. And so if I were to do x equals get subjects, and that's a terrible variable name, so I'm going to call it my grades equals get subjects, and then print my grades, I am indeed going to see that collection of objects, that tuple that was created inside the function. Now, what happens if instead of creating a variable with the tuple, we actually just put it on the return line? That should work as well. That's just going to be a literal of a tuple instead of a variable of a tuple, so this will still work. And now what we can try and do is let's see how clever Python is. And I'm going to remove the parentheses at either end that would ordinarily tell us that something is a tuple. And let's see what happens. And it indeed still works. Rithik, I think the transmitter is off. Receiver, oh, okay. Good. Okay, so now we can see that Python automatically, when we try returning multiple things from a function separated by commas, is automatically going to treat it like a tuple. And so when we print the return value, it's going to print as a tuple. But now we can do even more tricks in Python. Say we know how many things are going to be returned. And we might do this, for example, if we're just doing this semester's classes, and we might want to return Comp 101, Math 102, Chem 101, and someone's going to have a bit of a tricky semester. So let's call get this semester's classes. If we print that, that'll work. But because we know that every semester is going to have 4 classes, we could automatically have Python unpack that tuple for us and separate that tuple into individual variables. So I could do class 1, class 2, class 3, class 4. And now Python is going to automatically unpack the tuple and put the first item inside a new variable called class 1, the second item inside a variable called class 2, the third variable in class 3, and class 4, etc. So now if I print class 2, I'm going to get Math 102. Now, just quickly before we finish off, I want to show you one more useful thing that we can do with functions and tuples. So one thing we might want to do is actually take in a variable number of arguments into a function. So up until now, we've seen functions where you specify each argument. So for example, if I have my function getNums, and this function is a very boring function. Oh. Let's run that. I just see the 1, 2 that I put in. My function takes in 2 arguments. But now, let's say I want to make something like the print function, where you can give it as many arguments as you like. Well, what we can use is we can use our tuples to pass into the function as many variables as the user might want to provide. And so we'll do that with something like this syntax. And now we can pass in as many arguments to the function as we want using that syntax over there, which is going to enable us to have a function which actually accepts as many arguments as the user puts in, and this is indeed how the print function works. Now, one last note about functions and arguments for the time being. We have multiple different types of arguments that we can put into Python. We have the regular old ones that we've seen, like x and y, that I had there before. We have this special tuple type, and then we also have default arguments. And this is a special type of argument that allows Python to fill in the value of a variable, even if the user has forgotten to specify what it is, or has chosen not to. So let's say we want to make it optional for the user to enter a y value. And if the user has not entered a y value, it's just going to default to 1. So I could now do get nums 1, 2, and let's see what happens. It should return the sum of 1 and 2. Just 3 over here, correct. But now let's say the user's gotten lazy and doesn't want to enter in a value for y. Now, because we've assigned in the function prototype, in this line that defines what the function is, we've added a default value for y. We've said if the user doesn't enter anything, set y equal to 1. Now, if the user only enters in one argument, it's going to default that y value to be 1. Now, the order here does matter. You can't do it that way, because that's going to start confusing the Python program as to what you actually intended. Because like now we are unclear if this 1 is the value that the user meant to put in for x, but x already has a default thing, but this function's meant to have 2 things, and one of them's the default, which ones they meant. See how we're having that confusion trying to figure it out? The Python interpreter has the same problem. And so if you're using default arguments, they have to come after the non-default arguments. And with that, that ends our introduction to scope, functions, and tuples. And I'm going to give you a couple minutes for Kat to set up, and we will take a little break. Thank you very much.
Before we start, I have an announcement for those who think that this subject is not challenging enough for them. They want a real challenge. So as part of Australasian Language Technology Association, we are running a shared task, or it's sort of like a competition to develop automatic detection systems that are capable to distinguish AI-generated sentences from human-produced sentences. So the way it goes, so once you register, you get some training data. So the training data is an article. In the article, some sentences are produced by AI. Some sentences are produced by humans. And it's all annotated. So you know which sentence comes from whether it's AI or it's a human. So you use this data in order to develop your super cool system. So, and then on 30th of September, you see the new data that your system did not see before. So you need to check how well your system works on the data it has not seen before. So this is called test data, and then there's different systems from different teams. They are evaluated, and the winner gets $500. So if you want to challenge yourself and do something related to AI and see whether you can distinguish GPT 3.5 from human, you can register for this task. I'm happy to help because it's my area of research. Yes, you have a question?
What tool would you be using to do this task?
Well, you have to use some machine learning. You need to learn a little bit of machine learning and develop a system that captures the patterns. And we'll actually have an advanced lecture on language models and how to develop your own language model. So I'll be giving it like maybe in a couple of weeks. So, and using the content of that lecture, you'll be capable of doing this task as well. So I very much kind of invite you to attend that lecture. But of course, it's very advanced material. OK, so now let's go back to our lecture. So with Shannon, you already learned that you can use tuples to return multiple values from the function. So, and we also discussed functions before. And as programming deals with modeling, so let's create this toy model of the university. So suppose in the university, what do we have? We have university, the subjects, the students. And once the student enters the university, we need to create a record for that student, right? So the student needs to provide their first name, last name, date of birth, and this data should be stored somewhere in the system. So let's create a function. It will be, of course, a very simplified scenario. So the function should be called createStudent, and it should ask the user for their name, age, and whether they are graduate student or undergraduate student. And it should also automatically assign a student ID number based on the total number of students in the university. So, and then the second function, so our student is already in the system, and then they start enrolling into some subjects, right? So let's create another function after that that takes the student record and the subject name and creates an extra record that has the student ID and the subject code. And note that we follow this Melbourne Uni name of subject name. So we have this 4 alphabetic characters followed by 5 digits. And we assume that all undergrad subjects, they should start with 1000. Okay? And finally, we will also create another function that takes the students, the enrollments, and prints out everything. So it prints the student IDs and the subject codes they are taking. So let's start with create student. So create student, it should ask the user to enter the name, the age, and whether they are graduate or undergraduate. So let's go to Python tutor. So here is our Python tutor. So what do I need to put? Suppose you're part of software development team in the university. So how you start to approach this task? So you need to define the function, def, create student. So this function does not take any parameters because it will ask the user inside of the function. So we need to ask the user to enter the name. So what do you need to put here? So we need to ask, input, and we provide what is your name, right? So the function input takes this prompt as a parameter, and it returns a string to us. And the resulting value will be put in the variable called name. Now, what is the second string? Who can tell me? So we need to ask for the age. Let's just simplify. So we need to ask for the age, input, and the age. Is it enough? Suppose we would like to store age as a number, integer number. What do we need to do? Yes, so we need to transform this into integer data type because, again, the function input only returns a string. Then we need to have this flag is graduate. And we need to ask, again, input. And suppose we would like to say as graduate, we ask this question. And the user can provide either 0 or 1. What do we need to do with the output of the input function to transform this into Boolean? Anyone? So the function will just return a string, which is either 0 or 1, right? So what do we need to do in order to get false or true? What transformations do we need to do? So if you just put bool, what will happen? What do you think? So you still need to keep in mind that this is string. Both are non-empty strings. And both non-empty strings will be evaluated as true. We need to do extra conversion, right? So we need to convert this into integer. And then only after that, we need to transform this into Boolean. OK. So we asked 3 questions. Now we also need to assign ID. And the ID will be the total number of records in our system. So how do we deal with this scenario? So whenever we create a student, of course, we can say, OK, ID assigned to ID plus 1. Everyone is familiar with this notation. So it's actually a short way to say the following. So it's ID assigned to ID plus 1. But of course, we need to initialize our ID somehow, right? So if we create this ID inside of this function and assign it to 0, every time we create a student, we start with 0. It's a problem, right? we need to have the total number of times we call that function, right? We need to count the total number of times we visited this function. So instead of that, we'll create a global variable, ID here, assign it to 0. And then, in order to say that this ID inside of this function is the same ID outside the function, we need to put a special keyword, right? Otherwise, they will be considered as one local and other global. So we need to put this global keyword. And then it means that this ID is exactly the same as outside of this function. So, and inside of the function, we increment it by 1. So what it means increment, we increase it by 1, right? And again, I advise you, oops, there is a typo actually here, so just I forgot to remove the plus. So this is basically ID assigned to ID plus 1. Every time we visit the function, we increase it by 1. Again, the shorter form of the same thing will be the following. Okay? So we increased ID, and then we need to return a tuple, right? A record for the whole student data. So our tuple will contain ID, the name of the student, the age, and is graduate, right? The Boolean. Okay, so now let's try to call this function. Create student. And we put the returned value into the variable called, say, Tom. It can be any name. And then suppose we would like to print this student data. Okay? So now let's run it. I very much apologize for these advertisements from Australian Defence Forces for some reason. Yeah, I'm not sure how to turn it off. So let's go line by line. So we define the function, create student. So then we go to this ID, which is the global variable. It's defined in this global frame. So we have ID. Now we call the function. So we go inside of the function. And inside of the function, again, we see that there is this ID, which is global. And it means that we do not create a separate local variable inside of the function. If you do not put this global, you'll have the second variable inside of the function ID, which will be independent of this global variable ID. So let's put name, submit, so it's Tom, and suppose they are 18 years old, and suppose they are undergraduate. So the value is false. So here's our local frame. So this is local frame of the function. And then we increment ID by 1. So you see that the global ID changed by 1. Okay? So, and now we return the tuple. So this is our student record. And you see that we return this ID, then string, right? The integer value, the age, and the Boolean value. So in the tuple, you can have objects of different data types. And then we put it inside of Tom and print the resulting record. Is it clear? Anyone? Any questions? Is it clear? So again, if you do not put this global in front of the ID, you will have another second variable, local function variable, which is also called ID. And then you'll have to, of course, initialize this variable inside of the function. Otherwise, you get error once you reach this ID plus 1, because it's not clear what was the initial value. Okay, so this is our first function. Now suppose that the second function was implemented by your colleague. So if you start a software developer position, in most cases, you'll spend your time reading someone else's code, obviously. So you need to be able to understand it quickly. So who can tell me what's happening here? So we have this same, so this enrollments, which is the global variable, the tuple, which contains this student records. So, and then we see that we identify this as a global. The function takes this student, the whole record, as an input parameter, and the subject code. What happens in the third line? Who can explain me? What does this condition check? If not student, and then we take the fourth element. So we start with 0, so it's the fourth element. What does it check? So our student record is the following. So it's element number 0, element number 1, 2, and 3. So what do we have here? So it's the very final element. So if you start from 0, it's element at the position 3. The very final is our Boolean flag, right? So we check whether the student is graded or undergraded, right? So what happens here? So if the student is undergraded student, right? So the value is false, so the whole condition is evaluated as true. So we go and check whether it's undergraded subject, right? Whether there is a 1000 in the subject code. If it is, so we allow the student to enroll in the subject. So what it means, we just modify the current enrollments. Again, it's a shorter form to say enrollments assigned to enrollments plus something. So it's, if in the case of tuples, you have the following. So if we go to tuple, if we apply this plus operator to tuples, what will happen? What do you think will be the result? So we have two tuples, 2 and 3, and 3 and 4. So what will be the result of this sort of like concatenation? So the result will be just a single tuple that contains 4 elements, 2, 3, 3, 4. Okay? So by doing this, we just add this extra record in our enrollments. Okay? And because tuples are immutable or read-only data type, whenever we do something like enrollments, assign enrollments plus something, so we create a new object in the memory. Okay? Because tuples, strings, integers, Boolean, etc., they're all read-only. Whenever you modify, you actually create a new object in the memory. You cannot modify the same object. So in other cases, if this condition is not satisfied, we just print a message. Undergraduate students can only be enrolled in this 1000 subjects. And then if it's a graduate student, we are allowed to enroll to any subject. So we do not have any extra condition for them. So who can also try to identify potential problems with this code? Suppose, again, your colleague wrote the code and you're looking through the code, you try to interpret what's going on, and what do you think might be problem in that code? Yes?
Maybe like
Yeah, exactly. So this condition is very problematic. You'll have false positives, so-called. So if our subject is 31000, it will still satisfy this condition. So we need to make it more specific. So in order to make it more specific, we just need to check whether we start at the index 4 and the rest matches this 1000. Okay? So we are only looking at the part that is relevant for the digits, right? So we start looking where the digits start. So we skip the first 4 alphabetic characters, right? So again, if we go back to, where is our slides? Oops, no, we are not here. I lost the slides. Oh, okay, so I'm still on the slides. For instance, comp 10,001, right? So we start at position 4. So this is the position 4. Okay, so it's 0, 1, 2, 3, 4. So we just start matching this substring at that particular position to avoid the case where we actually have this 3, 1, something. Okay? So to avoid the false positives. Okay, any questions to this part? Is it clear or you have, yeah? Exactly. You'll be creating a new tuple. I will visualize this in Python tutor. You'll see that every time you create a new tuple, every time you modify tuple, you create a new object. Sorry? No, the previous tuple will be removed. So you just automatically clean. There's like special thing called garbage collector. It's everything that is not used, not referenced to. Okay. Now, the final thing. So when we have all our enrollments and the students, we need to print the student and the subjects they are taking. So what do we do here? So we have this function, print enrollments. And typically, if you have this enrollment, so all enrollments are stored in this global variable enrollments. It's a tuple of tuples, right? So based on what we have learned so far, we have to provide this line by line, explicitly going through each enrollment. So if we have 2 enrollments, it's not a problem. If we have 5,000 enrollments, it's a big problem. And of course, it doesn't generalize to any number of enrollments, right? The hard coding is a bad practice, right? We don't want to hard code. So how do we deal with this situation? Yes? Can we use a for loop? Of course. So you're a little bit, moving too fast with this course. So many of you already used the for loops, and this is what we are going to discuss now, how we do iteration and in which cases we need to iterate. So this is the major topic of this lecture. So we will talk about loops, how we implement loops in Python language. Again, iteration is just one final essential tool to make the computer to do something over and over again, right? In the extreme case, you can just be stuck in a loop and repeat something forever, but you should remember that algorithm should terminate, right? It should always terminate. But there are some eternal loops, such as while true. If you put condition while true, it's always true. You just get stuck. So what are those conditions where we want to repeat something? So for instance, we would like to move turtle 1 pixel to the right 10 times over, or play nyan cat 15 times. So we either know the exact number of times we need to repeat this action, or we need to go through some iterable objects such as string, character by character, right? Or tuple, we need to go through some tuple, or tuple of tuples. Or in some cases, we need to repeat something until some condition is satisfied. Okay, so there are different ways to specify the loops. So, and let's start with the most common type of loops. It's called for loop. So for loop is used when you know exact number of times you need to do something, right? And you can either specify this using special function range, or you just indirectly go through some sequence, iterable object, element by element. So if it's string, you go character by character, okay? So let's start with the for loop. So this is the syntax of for loop. So we have this for in construction. So in should be followed by some iterable object. Again, iterable objects are those like sequences, right? I just mentioned them. And you also define so-called loop variable. So, and then inside of the for loop, you have the statement block. So let's discuss an example for the case when you know exact number of times you need to go through something. So let's use this function range. So the function range gives you a range of numbers in that particular, so you start by default with 0 in this case, and then you finish at the element 10. So, and non-inclusive. Again, it's very similar to slicing. So the range function generates you a range of integers. And then you specify how you start, where you end, and what is your step. It's exactly like slicing. So, but instead of indexes, you have just these particular elements. And this is your loop variable. So every time you go through the loop, inside of the loop, step by step, this variable will be assigned that particular element of that step. So let me print I, and then let's also put this extra end. So who knows what does this end mean? This extra parameter end, does anyone know? Sorry? So yes, so basically instead of ending this string with the new line, so instead of switching to the new line, we just add the space every time we use this print. So let's visualize this execution. So we have this range of numbers. So it will start by default with 0 and end with 9. So it's 0, 1, 2, 3, 4, 5, etc. up to 9. Non-inclusive. Again, it's very similar to slicing. And the default step will be 1. So we now, you see that how I changes, 1, 2, 3, and so on, and up to 9. And we finish. OK? And again, we use this space just because I put this end as a space. If I do not put this end parameter, every time we print this number, it will be on a separate line. OK, so now we can also specify the starting element. I can say, for instance, that I would like to start with -2. And then I can say that I would like to print every second. So I just have the step of 2. So what will be the result? Who can tell me? So I started -2, and my step is 2. So each time I increment by 2. Yeah? 0, 2. Yeah? 0, 4, and up to which? It will stop at 8. Yep. So let's have a look. So it's -2, 0, 2, 4, 6, 8. That's right. And of course, I can also have this negative step, -2. But then I need to start with something else, right? So for instance, I can move the opposite direction, say from 10 to -10. Now I decrement by 2, right? So I subtract 2. So it's 10, 8, 6, 4, 2, etc. OK? Is it clear? OK, it's clear. So, and similarly, we can iterate through sequences. So I can, instead of this generating this range of numbers, I can take a sequence, ABC, and print every character from that sequence. So this I will first be assigned to what? So the I will be assigned to A, then B, then C. A, B, and C. OK? So if it's string, we just go character by character. So if it's a tuple, we just go through elements of the tuple. And similarly here, this is the solution to our enrollments problem. So we take our tuple of tuples. So enrollment is a tuple of tuples. So we go through this tuple element by element and print each individual tuple. So you can have a try at home. Try to re-implement it from scratch and see whether you have any gaps. But again, it's a very simplified model. Of course, the university has many more stuff to take care of, but this is just for you to practice. Okay, so we discussed this part, and yeah. Suppose we would like to also measure the length of the string, right, without using the function length. We can still use loops. How we do that? So we need to create this counter, myLen. Of course, we need to initialize it with some value. We start at 0, so this length of our string is 0. And we'd like to actually get the length of ABC. How we do that? If we use the for loop, each time we go through the character, we increment it by 1, right? So we increment it by 1, and once we finish, we'll get the length of ABC string. So this is exactly the same as you just copy and paste. But copy and paste is a very, 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 very bad practice. So do not hard code, do not copy and paste, okay? Try to avoid such a repetitive style of coding. So who can tell me what's going on here? Who can explain me what's happening in this code? What are we trying to do? You see, at least you can make some hypothesis based on the variable names. So that's why this naming matters, right? If someone called this as I, it will be much less meaningful. It will be much more difficult to understand what's happening there. So who can tell me what's happening in this code? What are we trying to count? Yes? Yeah, exactly. So we have this counter for this vowels. Of course, we just initialize it to 0, 0 vowels initially. And this word that we take as a sort of like input. And then we go through this word character by character. If, then this is probably a new construction for you. How to check whether this element appears in some string or a tuple. You can use this in operator. So if this character is either A or E or I or O or U, we increment this counter by 1, okay? So it's a very classic definition of vowels in English. And surprisingly, what do you think will happen with the word rhyme? Yeah, the word rhyme doesn't have any vowels according to the classic definition of vowels in English. So now suppose you also need to return the indices of the vowels. How do we modify this code? What do we need to do? If we want to get the indices.
Well, there's 2 ways we could do it.
Yeah?
We could use enumeration. Like you could have I and chart keep track of I.
Mm-hmm.
Or you could use a method to figure out the index.
You can make it much easier. The most typical scenario is that you take and generate the range from the length of the string, and then you go through the indices. So you access the string through the index. So each character will be accessed through the corresponding index. So this is the way you get the indices. So you take the word, take the length of the word, and then generate the range. So the range will start automatically from 0 and go until the length minus 1. And then in order to access each character, you just index, right? You take the word at this particular position. And if it's a vowel, you update your tuple that contains the indices. Okay, so let me just go through this example in Python tutor so you can see how it's getting updated. Okay, so let's edit the code. Let me try to copy and paste it. So we have this. Of course, from PDF, I got extra spaces, so I need to remove them. I very much apologize for this extra time. So what do we need to, okay, so this extra space here. Some extra spaces. Okay, so let's go through, not rhyme, so rhyme is not interesting. Let's go mamma mia, something like this. We have more vowels in this word. So, and let's see what will happen. Visualize. And we initialize our words. It's in a global frame. We initialize the vowels. It's an empty tuple at the very start. Please do not forget to initialize your variables, okay? It's very important, because otherwise your program will not be able to understand how you start. So, and then we go inside of the loop. Our I is automatically assigned to 0. So, and we take this character at the position 0, which is M, and check that, okay, it's not a vowel, then the next one. So we start incrementing. Each time we see a vowel, we increment it by 1, and we update our tuple. So we add the corresponding index to the tuple. So we see these vowels, and we every time we add the new index. So this is our tuple, and these are indices of the vowels. Now let's see how do we see that this is different objects every time we update these vowels. So let's print ID of that object. So ID is sort of like looking at the address in the memory. And you will see that this address will be changing. So we are kind of asking, who are you, vowels, right? So let's just go through this one more time so you can see how this object changes. So each time we update, so this is our first vowels tuple, so it contains only one index. Then we go to the next one, and we update. And you see that the object is changing. It's not the same object. Again, because tuples are immutable. They are read-only. Yes? This is the way we define the tuple. You can omit the brackets, but you need to have the comma. Okay, so if you remove this comma, you would like to see what happens? Okay, let's try. You'll probably, it's already saying like, I cannot continue. Yeah, because this will be interpreted as just integer. And you say that your vowels is actually a tuple. It doesn't know how to concatenate a tuple and an integer. So you'll have to put the comma. So the comma is the major indicator that this is actually a tuple. You can omit this parenthesis. Actually, I have not tried this particular notation, but we'll see. Let's see if it works. Yeah, it works. But for readability, please try to use these brackets as well, because someone will be reading your code. It will be much harder for them to interpret what's going on. Okay, so it's clear. Let's go back to the slides. Now let's do some practice. So suppose we would like to generate Mexican wave. So your wave starts at, we kind of illustrate the wave using Y, character Y, like this, and a number of X characters. So it's a single Y and then followed by X. So let me just start putting this over here. So we have this wave. So let's assume we have a short string, so it's Y and then X. So our result should be that we move this Y and to the right-hand side, one position at a time, until it's at the end of the string. So our goal is to have 4 X and Y. So this Y should move first to the second position, third, fourth, and so on. So how do we implement this? How do we move this Y to the end of the string and print all these steps? What do we need to do? Yes? 3 separate strings, which ones? Will it generalize to any lengths of this? Like if I put more x's, like over here, will it generalize? So yes, and another solution to this, so let's practice with for loops. Okay, so how we put this into for loop? So we need to iterate through this string, moving y at the right-hand side one position at a time. So let's do for I in range, then the length of this string, wave. Let's do -1 because we're just already there. And how we update this string. So we need to assign wave to something and then print the wave. So we update the wave in some way and then print it. So the second output should be x, y, xxx. So how do you, let's practice with indexing. So on, if you,
Index, right?
yeah?
So you said that the next one has to be x, y, xxx, right?
Yes.
So is that not the equivalent thing of just slicing it, but starting it from a different index? So
Yes.
starting it from -1.
Yeah, that's right. So you start with -1. We take the last index, and then
No, like in the slice, so go -1 colon, then -2.
but then you're just extracting, like what are you extracting actually? If it's just -1 to -2, will it extract something?
Okay. You need.
So we take this last, and then we can move it to, so we are moving this into forward, right? We make it the very first. So we move this last one, and then we actually don't need it anymore, so we can go until this -1.
Could we put that in one slice notation?
One slice notation?
Like, could we put it as -1 colon
So,
-1?
So what will happen then? So our idea here is that we take the last character and we move it forward. We take the last character, so we don't need the last character anymore. So we just read the whole prefix string until the very last character because we're just moving it forward.
Because so you're saying in the splice notation, it will only go up to the end of the string. It won't wrap around. Like you can't have it start at -1, then continue through to the back to the front of the string.
Yes. So let's print this step. So we go through, we generate the range from 0 to 5 non-inclusive. And then we update our wave. So this is our wave. So you see that we take this last x and we move it forward. And then we read wave until this last character, which is not included. So we kind of remove this last character because we moved it in front of the string already. Then the next one, and the next, and here we are. Okay? So let's go a bit quicker, so because we are a bit running out of time. So the second type of iteration is conditioning. So we have a particular condition, and while the condition is satisfied, we are running something. So what is the most common scenario here? For instance, you might have some sort of like input system, and you keep asking the user to enter some 3-digit code. So while the user does not provide this 3-digit code, you keep doing this, asking the user to provide the valid code. So while this condition is true, you are running the statement block inside of the while loop. Okay? So There is another way to organize while loops. So one way is to provide this condition that is either true or false. The other way to make this eternal loop while true. So while true is always true. So it means that inside of that code block, inside of this loop block, you need to have another condition to say when you terminate. And there is a special keyword for loops to terminate the loop. So it's called break. So if you do not have this condition and break, your program will be stuck in the eternal loop. It will never terminate. If you use such while true, you need to have the break inside somewhere. Okay, so break is sort of like return. As soon as you reach this point, you immediately exit the loop. So here is an example. Suppose we have this. We are asking the user to enter some 3-digit code. If they entered actually the string that has 3 characters, we do not check whether it's digit or not to simplify it a little bit. So if they enter something that has 3 characters, we immediately terminate. We just go and leave the loop. So otherwise, we reach this point, sorry, invalid code. So this error message, we only reach if that condition is not satisfied, if we do not go into the break condition. So, should we do? Let's probably skip this and go to the nested loops. So let's go to the nested loops. Suppose you would like to generate the deck of cards, right? Or generate a matrix. So in matrix, you have rows and columns. So it's 2-dimensional object. How we do that? What do we need to do? So we'll have the 2 loops that are nested. So here is an example. So this is our deck of cards. So in cards, you have the rank and the suit, right? And you need to provide all possible combinations. So for each rank, you need to combine it with each suit. So let's do this in this example here. So for rank and then for suit, we print, and we also do this new line thing. So what will be happening here? So this is a nested loop. So we start with this at element 2, and for that element, we perform the combination. We concatenate it with every element in this SHDC. So, and then we go to the element number 3 and 4 and so on. So this is what we generate. And once we exit the inner loop, we switch to the new line. You see here, it's outside of this inner loop, but it belongs to the outer loop. And we just switch to the new line when we finish. So how many combinations we'll have? Who can tell me? How many times we'll be running this print message? How many times? Yeah, 52. So it's 13 here times 4 here, right? If you have like a matrix that has like 100 rows and 100 columns, you want to generate every single value in the matrix, so it will be 100 by 100. Another thing that you can do is just more about representation. If you would like to actually get something fancier, the real suits of the cards, you can use the Unicode instead of this SHDC. So you'll provide this Unicode symbols, and then you can actually get the real suits. Let me just remove these extra spaces I got from PDF. Okay, so let's visualize the execution. And here's the result. Much fancier, right? So you'll discuss these text representations in a few lectures. So in the second half of the course, how you generate all these different fancy symbols. Okay, so who can tell me what will be generated over here in this code? So we have I in range of 8, J in the range of 8, and then we print some star sign. So what will be the result? And each time we go through this I, we also, like after we finish with the inner loop, we switch to the new line. So how many stars will we have? 64, right. So we have 8 here, 8 times 8 will be 64. So let me just put it again in Python tutor. We go through this step by step. So I lost the spacing again. Okay, so here it is. So we go through this, and here is the result. So it will be the square comprised of these star symbols. So we go, every time we finish this inner loop, we switch to the new line, right? So if we remove this print empty string message, we'll just have a single line. Because here we also do not switch to the new line, because we just say that we should end with empty string. So, okay, is it clear? Now we go to the next one. So who can tell me what will change if I put this extra condition here? So let me put this inside here. So we have before the inner for loop, we have this extra condition. We check the modular after the division by 2. If it's 0, so we just put the space and just say that we stay within the same line. What will be the result? Who can tell me? So every second string basically will be shifted a little bit by 1 space. That's right. So we start with I, which is 0. So the modular is 0. So we shift a little bit. And we print this 8 stars. Then we go to the next one. So I modular 2 is not 0. So we skip this condition. And so on. So the next one, again, we move a little bit to the right. We skip. And so on. So it's just like every second line will be shifted a little bit. OK? So now what I encourage you to do at home, and we'll probably start with this example on the next lecture. So there are 2 class exercises. So one is this one. So you need to find the minimum I such that the sum up to I, from 0 up to I, is greater than some given x. This is exercise 1. And the second exercise is if the sum of the digits of some number, it doesn't have to be that huge number, is A, and then the sum of the digits of A is B, which is the sum of the digits of B. So try to do that at home, and on Friday we'll start with these 2 exercises.